Hi, it's bizarro bit of industry kit teardown time. I got this in the mailbag. I think it was from someone anonymous. Thank you very much who sent this in, and I guarantee you are not going to get this through airport customs. There's no chance whatsoever. This is incredible. What is this thing? I didn't tell you in the mailbag episode, but what it is it's actually something you would totally not think of unless you're in this particular industry. It's an ultrasonic gas leak detector. It's got 4 ceramic ultrasonic sensors on top here. It's got a digital readout like this. I don't know, you can set it up somehow. I'm not sure what the top interface is. We'll find out shortly. And the reason it's in this sort of like a gas cylinder type construction like this is because this is explosion proof. Basically, this is rated to, we'll find a standard on here somewhere. Here we go. It's the EXD standard plus of various other things, but this is basically a like explosion fireproof standard. It basically means if there's any failure inside this thing, nothing can escape this thing. I mean, it'd have to be some massive internal pressure for it to escape, because this is a gas leak detector designed for use in potentially explosive, industrial factory environments where you got, pressurized gas pipes running everywhere filled with, who knows what flammable pressurized material. And if you get a leak in any of the pipes, you get a burst or a seal leak or something like that, then depending on the pressure differential, the temperature and the type of gas and, size of the hole and all sorts of things, it can actually make an ultrasonic sound, and that is what's picked up by these 4 ceramic ultrasonic sensors on here. So I guess they're in this arrangement to get like a 360-degree thing. You're supposed to mount this like several meters off the ground, like on a pole or something. That's why it's got like these big mounting posts here, and it can be electrically earthed, of course, down to mains earth here. So, there's no sorts of funny business going on. And it's just absolutely incredible that like you wouldn't think an ultrasonic sensor would look like this, but sure enough, there it is. So it's maximum power consumption, 160 watts, and we'll see why, hopefully, in the teardown. So this is a type NSM SU343A, a 30,000 serial number, manufactured in 2013. Do not open when there's explosive atmosphere, manufactured in the UK by Net Safety. And it's the Banshee 343 for those playing along at home. And do not open when explosive atmosphere is present or when energized. Well, it's not going to be energized. I don't even know where the cable port is on this thing. Is this like up the top here? But, oh, geez, I tell you what, I so want to actually, after this teardown, I so want to put it back together and actually, like, design a little board that goes in there to drive this LED display and have a countdown timer on it. Oh, that's like... oh man, yes, why not? It's got to be done. So yeah, who knew that when pipes leak, they can generate not only audible sounds, the hissing sound, but they can generate ultrasonic sound as well. And this is designed to measure a 40 meter radius and works from 25 kilohertz to 100 kilohertz, and can work up to anywhere from 50 dB to 160 dB pressure levels. And it's got all sorts of, it's got fail-safe sensor systems, and also apparently like self-cleaning sensors in there. So I'm curious, and it can actually generate and do self-tests and stuff, like a periodic self-test. So I believe it has like internal generation or something like that. So I'm curious to see like what's happening in here. And it also can do like internal heating and stuff like that as well. So I possibly expect to see, some sort of like, heating elements, and I don't know. Let's tear it down. I guess I'll start by taking off this top cover here. Is this where the interface is? Because it has both a 4 to 20 milliamp current loop output and also an RS485 output as well. So this is going to have some serious O-ring sealing, I suspect. So, oh yeah, I can see a gap in there. Yep, there we go. And yeah, it's supposed to have an infrared system as well, and I believe I can see an infrared transceiver down there as well. I think it's designed to like report back to like a central operator or something. So I don't think there's anything internally, like a buzzer or anything that goes off. So, oh, no. Well, hello? That's it. What? I don't know. Got no idea what that is. Read the manual, I guess. So I'll take off one of these ultrasonic sensors here, but I'd imagine that, you know, with this huge, basically pressure vessel kind of thing, I don't know if like the sensor will be actually have a sealed interface between the sensor itself and inside, because it kind of seems to defeat the purpose of this huge thing if you've got this relatively tiny sensor head here. But yeah, there we go. Yep, that's all. Wow. Yep, that's what you'd expect. Look at that. Oh, this is all machine, like this is all part of the machined part of this big head here. Oh, how much are these things? Anyway, that's got a connector interface like that. Is that like a high pressure connector interface? But there's your sensor. So it's just a 3-pin jobby down in there. Once again, these are all, they're just the machining that goes into this. But, oh, does that come out? Yep, that comes out. So there's our, oh, there you go. Each individually tested. That's our ultrasonic ceramic sensor head. Oh, we can take that apart later. It almost looks like, inside this, that almost looks like it's a port going in there. And that's, yeah, sure enough, that's got an O-ring on it. That may be part of the pressure self-cleaning system. So you may have to hook up, as a guess, I'd say hook up a pressurized gas system, ironically, to actually self-test, like to actually apply pressure to the sensors to actually test them. Aha, no, it turns out these are the actual EXD-rated cable glands that are designed to get the cables in and out to the terminals. Here's the diagram over here, and this has all the terminals in the bottom here. Ah, there you go. So here we go. Yeah, that's why they've got the cable here, because this thing can be like, you know, hanging from a roof. There's various, I'll put up a photo, there's various ways to, like, you know, mount this from the wall and stuff like that. But look at this. I mean, isn't this just glorious? Look at all these massively, this whole thing is just, you know, one big machined part. These gigantic cable glands coming in and out. But this is what you need in terms of like cable glands and like interface to go into something that's designed for an explosive containment atmosphere. I mean, it's just incredible. And yeah, they've gunked up that down there. So yeah, no wuckers on that. So that's how, I guess, cables from this board go into the main chamber, is it? Wow. And that's got Grovelly Detection Limited, so I don't know, is it another company who's involved in the design of this thing? But yeah, there's your 4 to 20 milliamp current output, and the RS485 interface as well. So wow, like I can just, what's going to be in the rest of this thing? Like just the interface to get into this is incredible. And there you go. There's the base of that board. Each one of those got a ferrule on there, and it's just it's nice interface. There's a bit of protection stuff on the back, but yeah, geez, that's just a really nice interface. And that down there is just, yeah, they've just sealed that going into the main chamber. They've sealed the thread and also gunked up the entire cable. But then you can have pressure, of course, being leaked through the cable, you know, through the gaps in the cable. So I don't know how they're taking care of that, but yeah, we'll find out. And of course, this probe thing sticking out here, which they got 2 holes down the bottom there, so I guess it can, I don't know, go into either one. There's only one option to come through, but this would be the ultrasonic transmitter, which is designed to actually, you know, test this sensor, because it can go down there and then it can simulate generating the ultrasonic signal and test out each individual sensor periodically. Yeah, so the reason that they have to go to all this interface here is because, of course, one of the risks in explosive atmospheres would be a spark due to a loose connection on something like this. You know, when it can draw significant amount of power, for example, when it's doing its ultrasonic sensors and cleaning and testing and whatnot inside, as you saw, like 60 watts or something like that, power consumption. So if you've got like a loosey-goosey connection on one of here, you know, and this is just out in the open, flapping around in the breeze, then that can cause a spark in an atmosphere. So they have to have this interface just for the connections, and then another interface inside the main chassis itself with the other electronics inside here. So yeah, just the connections need their own physical protective interface from the atmosphere. All right, I think I've loosened all those bolts off. Yeah, they can actually pop out. Yeah, there we go. 6 large ass bolts. So let's see. I don't know if I have to take the sensors off first, but let's try and get this. Can we get this open? Wow, this thing is thick as, let me tell you. It's absolutely incredible. So how much do these things cost? Brand new. I know they like, you can buy them. I checked on eBay. You can buy one for like $300 secondhand on eBay. But whoa, there we go. We're in. Now, there's a few loosey-goosey washers floating around in there, so I think somebody's had a Harry Hacker on this. But yeah, I don't see any other like any other sealing inside there for the penetrator down there, or I don't see, oh, is it? No, there's no gunking on the end of the cable, so they're obviously allowing for the pressure to be able to like seep through the cable and stuff like that. But I guess, you know, the standard satisfy all that. I don't know. If you've got experience in those sorts of standards, leave it in the comments. But wow, all the electronics here on this can, and that's interesting. We've got wires going up to the top here, and this is all gunked. All in here, that's that port that we took off on the top, which didn't seem to do anything, but there is something connected to there. So there you have it. We've just got like a board on gigantic standoffs that just sits in there. Nothing fancy-pantsy, you know. There's a micro and a few other things, you know. There'd be like an ADC and stuff to measure the multi-channel 4-channel ADC system to measure the ultrasonic sensors, and I don't know how they'd be sampling those. But there's a couple of adjustment. They aren't trimmer pots. They're actually like to set a code. So I don't know. Does each one have like a, you know, a coded type system and address system, I guess, for the, you know, RS230, RS485 line. So there's the entire PCB there, and these were the two cables coming in. You know, you've got your RS485, and you've got your connections for your heater and other stuff. We've got relays. They'd be, you know, largish relays. They'd probably be switching the heater off and on. Would that be the heater connection over there? I'm not too sure. Got a couple of ribbon cables going off. We've got another thing out here, which is plus minus 20 volts. Is that, oh no, heat 1. Is that going off to the heater? And M1, I don't know. It's got a couple of, you know, buttons for like production testing or whatever, and some extra mode jumper switches, something like that. But yeah, not a huge amount. We don't really care about the PCB. That's not the interesting thing here at all. Although I guess people want to know what the micro is. Well, it turns out that's a Xilinx CPLD. So wasn't expecting something like that in there. And the only thing that looks like a microcontroller in here that I can find is this thing. Near to impossible to read the number on. But maybe I can get that. I know it's an NXP jobby, but I can't read it on the camcorder screen. Yeah, sure enough, that's an 8051 jobby. No surprises there, really, because, you know, this would have dated back to an old design. I'm sure many decades old, and 8051 is all you need for something like this application. Why, it's got a CP, a Xilinx CPLD in there. That's a bit confusing. Got the ULN 2803 relay. That's for driving the relays and stuff, and other miscellaneous stuff for acquisition and whatnot. I couldn't pull a part number off that, but that's obviously doing like the ADC interface. There's got an LTC, probably a serial converter up there, something like that, and a few other CMOS stuff, and Bob's your uncle. What's underneath? Well, first of all, got a heatsink on the bottom there, and that's got some, don't know if you can see that, some bent over TO220s there, so that's just doing some regulation, and so there your voltage regs tied onto there. They're just using that as a small internal heatsink, and there you go. They're interesting. They look like little reed relays, maybe. Are they? Oh no, that'd be optocouplers. Oh, yeah. There you go. The component of the week award goes to this what looks like a do-it-yourself opto isolator. We've seen this once before. I can't remember what it was in, but obviously, look at the PCB clearance in here. We've got like at least an inch of PCB clearance. I'm surprised there's not a routed slot under there for good measure. But basically, yeah, infrared LED and infrared photo transistor on this side here, and this is the isolated, electrically isolated interface going over there. So, and is that one of those DC to DC converter, isolated converter blocks up there? Maybe, but look at the fuse. Oh my, they've soldered it down to the board. Oh, it's terrible. Muriel? By the way, all of these boards are conformally coded. You can tell by the sheen on them, so it's often not easy to read part numbers through that. But yeah, no surprises for finding conformally coded board. But yeah, that's obviously an interface. These are your 4 sensors. So yeah, they're just getting that data across the. So are they doing the digitization here and then getting it over digitally? No, well, it turns out these are 4000 series CMOS. These are 4051 analog muxes, and this is a 4093. So, yeah, it's all analog on this side. Turns out this device down here is an SA614. This is an FM intermediate frequency modulator down here. So yeah, that's how they're doing it. So they're just muxing the 4 channels by the looks of it, and they're just getting some optical isolation, and then you've just got an IF amplifier down here, and then this sampling is done on the digital board. I was just checking that there was nothing else inside that can. Got an insulating sheet. They've got a couple of these insulating things on the side of the can there, but no, that's about all she wrote. So yeah, right off the bat, I'm not seeing this supposed like heater interface thing, and the channels, the 4 channels there that are going down. Sorry, it's haven't got much light in there. Put some extra light in there. You can see that they've got this potting compound in here, and all of these wires. This is how they, of course, get the pressure interface going over to the sensor itself, and that's why they had to use the connector interface, because they would have used a pressure rated connector as well for that particular interface over on the sensor here. So yeah, that would go over to the other side of this connector here, and this would be a proper pressure rated connector. So yeah, you take all the issue out by having the interface there. But there you go. They've got something down here. Got a little tiny board down there. I think, yeah, tiny ribbon cable did go off to it. I assume that's like a little temperature sensor, maybe, down there. And it's just attached to the chassis like that. But, yeah, there you go. So, but interestingly, look what's in here or not in here is these threaded things. These go down to those, what I thought was like the ultrasonic transducer to generate like the test signal, but these just don't seem to go anywhere. There's no cables going to them. There's no nothing. So there's nothing doing there at all. Yeah, so I can only think that this is like a option that is not installed in this model, perhaps, because obviously, there's a purpose for that, and they do specifically say that this does have self-cleaning. Yeah, and here's the detail on that. It says it has a patented Failsafe sonic Cowl system. Our fully diagnostic system runs an automated broadband self-test every 15 minutes, applying a true pressurized gas leak to confirm each sensor's detection capability and removes any potential external contaminants such as sand, oil, or dust. And well, sure enough, I mean, to do it at each individual sensor, you need an individual, transmitter transducer there to generate the acoustic, the ultrasonic signal that's going to go into the sensor. So but there's nothing hooked up to it. It's just, there's no wiring at all. So it's just a cylinder. So yeah, an option not fitted perhaps. And the good news, that display board down in there, it's just got a ribbon cable interface. So yes, I could design a board that just connects to the other end of this ribbon, and I can get that board out, and then I can reverse engineer that. Looks like it just has some serial display drivers, just like the old 4000 series CMOS or something would be my guess. And then I can just drive that display. That might be a nice little mini project. Leave it in the comments down below if I get enough thumbs up on this video, and I'll leave a comment down below if you actually want me to do a little mini project actually designing a little counter interface for this thing. In fact, you wouldn't even need a microcontroller. You could just, if it's like a serial thing, you could just have a couple of 7.4 series counters or something like that, and it's and then the infrared thing to actually reset the thing. And we've got, of course, no shortage of space inside this thing for you could have a battery pack that lasted forever. You could have this digital display work for like a decade or something. And you could have a little remote control system that sort of resets it, and that'd be groovy. Yeah, if I get enough thumbs up down below for the comment and this video, I might do that project. And there is inside the ultrasonic ceramic sensor. That's all the details we've got. It's, some proprietary sensor thing. They've got like a green earthing wire going there just to make sure that the metalwork is earthed, but it's just 2 pins. I don't know what that is in there. Might have a little bit of, is that gunked up? Is there some preamp circuitry under there or something like that? But anyway, that's just a real high pressure capability ceramic ultrasonic sensor, and of course the specialized pressurized, pressure rated, I guess, interface connector down there. So that's all she wrote. So there you have it. I hope you found that as interesting as I did, because when I took this out of the mailbag, I had no idea what this thing was. Of course, spending a long time in the underwater marine industry, I'm used to seeing pressure vessels like this for ocean bottom electronics, underwater high pressure stuff. But in this particular case, it's not. Well, it is a high pressure chamber. It's designed to, if something goes wrong with any of this electronics, and I don't know where that heater was, so I don't know, obviously is not inside this thing, and so it can take significant amounts of power, and you get a spark from one of the connections or something like that, and you've got a pressure leak, because you have to assume worst case scenario, you do actually have a pressure leak, and at the same time this electronics has failed, then you don't want the gas igniting or whatever in your factory, and your whole factory goes up. So these are intrinsically safe and pressure rated to the EXD standard. I won't pretend to know all the ins and outs of that, but it's an international standard for these sorts of contained devices, so that they don't ignite flammable atmosphere. And it's it just looks like some mine or bomb or something like that. It's just demonetized now. As I said, try and get one of these bad boys through airport security. Please leave it in the comments down below if you actually have tried to take this on your carry-on. Good luck explaining it, especially with a countdown timer. Anyway, if you liked it, give it a big thumbs up. As always, discuss down below in the comments or over on the EEVblog forum. Catch you next time.